Welcome, welcome. Feel free to shuffle in and take your seats. We'll be starting up as soon as this 5-minute hourglass timer runs out. Okay, that's the timer, 5 minutes, so let's get ready to get started. Today I'm going to be working through a course on the website Boot.dev, and this course is now called Learn to Code in JavaScript. It was formerly called Introduction to Coding on JavaScript, and that's the name that you'll find on some older videos on my YouTube channel. But now it's Learn to Code in JavaScript. So with that, let's get into it. This is chapter 3, starting with comparison operators. I'm going to be reading from the course and also experimenting with some things along the way. There's a nice interactive included coding terminal over here, or coding editing pad, or whatever you want to call it. Anyway, to get started, comparison operators. When coding, it's necessary to be able to compare two values. Boolean logic is the name for these kinds of comparison operators that always result in true or false. I'm going to take a pause right there and point out that it's interesting that it's always true or false. There's never a maybe. Whereas a lot of questions you ask, maybe or I don't know, might be a reasonable answer. But in programming, when we work with Boolean logic, it's always either true or false. I think that's an interesting thing. So the operators, we have less than, greater than, less than or equal to, greater than or equal to, equal value, equal type and equal value, not equal value, not equal type or not equal value. That last one is kind of interesting, and I'm going to dig into a little bit, but let's go through these examples. I'm going to comment out. Oh, can I comment out? How do I comment things in JavaScript? I think it's // yeah. So let's just console.log 5 less than 6. Try that example. I know, try again. I know I'm doing it wrong. Maybe I won't run actually every one of those examples. I don't know if I can handle the sorry, try again so many times. So 5 less than 6 evaluates to true, 5 greater than 6 evaluates to false, 5 greater than or equal to 6 evaluates to false, 5 less than or equal 6 evaluates to true, 5 equals double equals 6 evaluates to false, 5 triple equals 6 evaluates to false also, 5 not equals 6 evaluates to true, and 5 not double equals 6 also evaluates to true, because although they're the same type, they're not the same value. And that leads to an interesting point. Let's try 5 not equal quote 5. What is this one going to say? False, because they are equal. But if I do not double equal, then it's true, because they are in fact not the same type. That's interesting. Note on equality. Triple equals 1, 2, 3, and not double equal are used more often than double equal and not equal, because it's more common that developers want to ensure that two values are the same type and the same value, rather than just an equivalent value. For example, let player health string equal 100, let player health number equal 100, player health string double equal player health number is true, player health string triple equal player health number is false. That kind of touches on the same kind of idea that I was playing with over here. Assignment. Change the operators in the code so that each statement evaluates to true if it doesn't already. So let's uncomment this stuff. Change the operators in the code so that each statement evaluates to true. We need 5 less than 6. We need 5 not equal 6. We need 5 double equal 5, because they're different types, but they evaluate to an equal value. And this one already evaluates to true, so we can just run. Oh, hey, this little thing kind of dances when you're ready to move to the next thing. That is kind of cute. Ha! Do you see it dancing up there? I'm gonna let it dance for a little bit and see if there's any questions in the chat before I move on to the next bit. Oh, also let's get a longer hourglass timer set up, so I know to take a break eventually. Okay, good enough. Now let's look at comparison operator evaluations. When a comparison happens, the result of the comparison is just a Boolean value. It's either true or false. Like I was saying before, it's always one of two options. There's no in between, there's no maybe. Take the following example. Let is bigger equal 5 greater than 4, and let is bigger equal true. In both of the above cases, we're creating a Boolean variable is bigger with a value of true. Since 5 greater than 4 is in fact true, is bigger is always assigned the value of true. And okay, the course raises the question, why would I use the comparison if I can just set it to true? Like up here, is bigger, we could just give it true. Why did we need to do a comparison between 5 and 4 since we already know the answer with 5 and 4? Well, let's see what the course says. You wouldn't in this case. However, let's imagine instead of hard coding the numbers 5 and 4, we had some dynamic variables that we don't know the values of. For example, perhaps you're making a video game and need to keep track of players' scores. In order to calculate who wins, you would need to write something like, assuming player 1 points and player 2 points are defined and changed somewhere else in the game's code, we have let player 1 wins equal player 1 points greater than player 2 points. Console.log player 1 wins. Prints true when player 1 is winning, otherwise prints false. I should put my phone on silent. Assignment. Use comparison operators to assign the correct Boolean values to the missing variables. Don't edit above this line, don't edit below this line. So here we go. Is Bob taller than Elon? We set Bob height greater than Elon height. That's going to come out to true. What about Sarah taller than Elon? This is going to come out to true. Sarah height greater than Elon height. And finally, Jill taller than Sarah. Jill height greater than Sarah height. I'm curious what this code does. It console.log, so just prints the type of each of these variables and then their value. Great, good job. Okay. On to the next one. Comparison practice. Let car size equal 4, let truck size equal 5, let is smaller equal car size less than truck size. Is smaller is true. Assignment on line 4, create a variable called enough armor and set it to true or false depending on whether hero armor is greater than or equal to enemy damage. And it's going to console.log whether or not your armor can withstand the enemy's blows. Create a variable, let enough armor equal on whether hero armor is greater than or equal to hero armor greater than or equal to enemy damage. And we see that the result is going to be false. Okay, cool. Changing in place. It's fairly common to want to change the value of a variable based on its current value. For example, we could have let player score equal 4, player score equals player score plus 1, then player score now equals 5. Fair enough. Then let player score equal 4, player score equals player score minus 1, player score now equals 3. And, you know, this slipped right by me, but the course points out that don't let the fact that the expression player score equal player score minus 1 is not a valid mathematical expression be confusing. It doesn't matter, it is valid code. It's valid because the way the expression should be read in English is assign to player score the old value of player score minus 1. This is an example that comes to a book I was reading the other day on stream that talked about declarative versus procedural knowledge. In a math equation, you would declare that player score is equal to player score, just like that. And that would be a declarative fact. But here, we have a procedural, not a fact, but a procedural piece of information that says player score minus 1 is the thing to do, and then assign it back to player score. Okay, assignment. Add 234340 to the value of player score, then print it. It's bugging me out that I can't do command / to undo comments. So we're simply doing player score equal player score plus 234340. Let's run that. Correct, good job. On to the next dancing arrow. Increment / decrement. If we're changing a number and simply want to increment add 1 or decrement 1, there are special operators for that. Let shield armor equal 4, shield armor plus plus, shield armor now equals 5. Another example says let shield armor equal 4, shield armor minus minus, shield armor now equals 3. Notice that shield armor plus plus is just shorthand for shield armor equals shield armor plus 1. Why does it need 2 pluses? I know this is like a thing in a lot of languages, but I wonder why we can't, because I guess 2 pluses makes it clear that we're not talking about shield armor plus 5, and we just forgot to write the 5. Okay, assignment. Decrement shield armor 5 times and print it after each decrementation. That's an interesting word. Shield armor minus minus, and we'll just do that a bunch of times. Shield armor minus minus, shield armor minus minus, shield armor minus minus, and shield armor minus minus. Okay, that's correct. Don't know what that has to do with comparisons. I guess we could compare whether it's less than what it was before, but I think it'll come together. If statements. It's often useful to only execute code if a certain condition is met. So now the course shows us the syntax of this. We have if, paren, condition, close paren, braces, do some stuff. And the stuff only happens if condition is true. Remember, going back to what I was saying, it's always either true or false. There's no maybe. For example, if Bob's score greater than Bill's score, console.log Bob wins. The assignment is take a look at the code, edit player health on line 1 so that the code prints dead. Don't edit code below this line, but let's do look at the code. We have if player health equals 0, console.long dead, and we have if player.health greater than 0, console.log alive. I'm going to be a little bit cheeky here, and because this only uses double equals, I can use quote 0 instead of just 0. I wonder if this will work, or if it's gonna, if there's like something clever in the background that's gonna tell me I did something wrong. Let's find out. It got the right result, so it's happy. Just to make it clear, I could have done let player health equals 0 as an integer 0 or a number 0. Does it come through as an integer? I forget what the data types are in JavaScript. I probably learned that in this very course and then forgot about it. But correct, great job. This is more of the same. Complete line 4. It should only log the warning if number of swords is less than number of soldiers. Okay, so we write a condition here. Number of swords less than number of soldiers. It's going to console.log. We do not have enough swords for the army. Oops, I didn't mean to move that down at all. And it says that's correct. Let's move forward. If else. An if statement can be followed by 0 or more else if statements, which can be followed by 0 or 1 else statement. I guess statement, not statements, because there's only one of them. For example, if score is greater than high score, console.log high score beat. Else if score greater than second highest score, console.log you got second place. Else if score greater than third highest score, console.log you got third place. Else console.log better luck next time. So this is the syntax. We have for starters we have just a normal if statement, and then else if comes along and looks a lot like an if statement, but it has the else if keywords. Let's see what the course says about it down here. First, the if statement is evaluated. If it is true, then the if statement's body is executed and all other else's are ignored. That makes sense because it says else. If the first if is false, then the next else if is evaluated, so that evaluates this score greater than second highest score. Likewise, if it is true, then its body is executed. That's the you got second place, and the rest are ignored. If none of the if statements evaluate to true, then the final else statement will be the only body executed. So if this condition and this condition and this condition go all to false, then we fall to the else case and we execute the better luck next time. The assignment says, complete the code, it's missing some conditions. It should print dead if player health is 0, otherwise it should print injured if player health is less than 5. If neither of those are the case, it should print alive. So what did it say? It said it should print dead if player health equals 0. I'm going to do a triple equal 0. Else if player health, it said if it's less than 5, then we console.log injured, else we console.log alive. And I'm going to test all of these cases. So let's try it with 10. We should see alive. I'm going to try it with 0. We should see dead. And go back to 4, which is what it was in the first place. Then I wasn't really supposed to edit that. And see if it comes out the right way. And yeah, it says injured. Okay, moving forward. Losing your motivation is the worst thing that can happen. Invite a friend to do your course with you. If you're enjoying the course so far, invite a friend to work on it with you. Well, I'm kind of inviting the chat to work on it with me. Does that count? Oh, I got it. I completed the course. I don't want to go to the next course. I want to continue working on this course. If-else practice. Here are some basic rules with if-else blocks. You can't have an else-if or an else without an if. You can have an else without an else-if. So let's break that down. Can't have else if true no if. You can have an else without an else if. So you can have if condition else do if condition do stuff else do other stuff. Okay, that makes sense. Remember, to check if two values are the same, use the triple equal operator. Let same equal 5 triple equal 6, same is false. Same equal 6 triple equal 6, same is true. Okay, assignment. There is a bug in our code on line 4. Edit the code so that if current player name is the same as high scoring player name, it logs you are the highest scoring player. If they aren't the same, it should log you are not the highest scoring player. Oh, it's supposed to. On this condition, we have the wrong operator. We just need triple equals, so that when they are equal, it'll say you are the highest scoring player. Okay, fair enough. If-else practice. Here are some basic rules with if-else blocks. I think we might have read this already, but let's go through it anyway. You can't have an else if or an else without an if. You can't have an else without an else if, provided you have an if. You can have an else if without an else. We didn't cover that one before. Can have if condition 1 do stuff, else if condition 2 do other stuff. That's the end of it. We don't need to have an else, although it's nice to have an else to catch in case both of these conditions were not true. Assignment. Edit lines 5 and 7. They're missing their conditions. Oh, sure enough, they are. If current player name is the same as high scoring player, the code should print you are the highest scoring player. Okay. So we just drop in current player name and say that triple equals high scoring player name. That will log you are the higher scoring player. Else if current player name triple equals lowest scoring player name, then you console.log you are the lowest scoring player. Okay, let's try that. Okay. That works. What do we say, chat? Have we learned something? How much time we got left on this? A little bit of time still, but I'm actually, since we've come to the end of this section, I'm going to call a stream break. BRB screen. Okay, that's that 5 minutes. How are we feeling? Ready to go into the next section? I think I am. So go to next. And go change the scene. Okay, chapter 4, loops. Loops are a programmer's best friend. Loops allow us to do the same operation multiple times without having to write it explicitly each time. I was watching a streamer recently who talked about, CockroachDB, and talked about it's a database that's implemented in Go, and on the query side, when you're querying things, any code that gets executed for each row is going to be executed potentially millions of times. So even the tiniest bit of not automation, what's the word? Improvement in efficiency matters a million times over. So that's just a side note about loops. So, for example, let's pretend I want to print the numbers 0 through 9. I could do this. Console.log 0, console.log 1, console.log 2, okay, I won't read all of them. All the way down to console.log 8 and console.log 9. Even so, it would work this way, however, it would save me a lot of time typing to use a loop, especially if I wanted to do the same thing 1,000 or 1,000,000 times. A for loop in JavaScript is written like this. Okay, that's the assignment. So let's go here. For paren let I equal 0, semicolon, I less than 10, semicolon, I plus plus end paren, brace, console.log paren I. And the course is going to break down what each of these things mean. Start with I equals 0. That's the let I equals 0. If I is not less than 10, exit the loop. The converse way of saying that is, if I is less than 10, keep going with the loop. And add 1 to I. That's I plus plus. Remember plus plus from a few videos ago, or a few chapters ago, or a few exercises ago, or depends on how I end up packaging this, I guess. Go back to step 2. And to review, step 2 was this: if I is not less than 10, exit the loop. The result of all this is that the numbers 0 through 9 are logged to the console in order. What's the assignment? Complete the missing sections of the for loop so that it logs the numbers 0 through 99 to the console. The first thing I'm going to do is put in the 0 through 10 and just convince ourselves that that works. Then I'm going to reset code, confirm. Anyone in chat want to speak up on what I should write in here? Oh, let's this timer is almost done. Once it's done, I'll turn it over into keeping track of the next section. So we want the numbers 0 through 99. So I'm going to make a mistake here. I'm going to say I less than 99. And then let's move on to the last part. What do we want to do? We want the numbers 0 through 99. So we can use I plus plus. And let's just run that. Oops, try again. What went wrong? Well, I said I is less than 99. It's only going to execute line 2 if this condition evaluates to true. When we get to I is 99, it will evaluate 99 less than 99, which will come out to false, and then it'll say, okay, we're done, time to exit the loop. So I actually, in order to print the numbers 0 through 99, I have to say less than 100. Run code. Okay, gives me correct. Good job. And there's my timer ready to flip over. Moving forward. Loops. Okay, this is the same information about for loops. Let's, for practice, type out the 0 through 9 for loop again. Oh, actually, let's look at the assignment first. Write a for loop from scratch that longs the numbers 0 to 199 to the console. Okay. For paren let I equals 0. So we're starting at 0. A semicolon to say we're done with that part. We'll say the condition is as long as I is less than 200, we keep going. And every time we increment I by 1, so I plus plus. And the rest is just braces, yeah, and console.log I. Right, great job. Let's show that typing job one more time. Just it's good to review. For let I equals 0, we start with I equals 0. I less than 10. Oops, 200. We're going from 0 to 199, and I plus plus, we're pushing I up by 1 each time. Console.log I. Try that again. Correct, great job. Good. Assignment, edit the for loop to print the numbers 5 through 15 instead. So we already have the loop set up to give us 1 through 10, but we're starting at 5. We want to go up to 15, so I could write 16 here, or I could remember from the conditionals in the past section that maybe I can write I less than or equal to 15. How does that work? Yep, that prints the numbers 5 to 15. Inclusive of 15. That's what the I less than or equal to 15 does here. Loop review. We already did that. Why is this highlighted? Possibly because I already answered this question. Why would you want to use a loop? Because the computer understands loops better than repetitive code. Well, that doesn't really come across. The computer doesn't really understand one any more than the other. Another option is because loops speed up your app. If anything, loops can slow things down because it's an easy way to write, making your app do something over and over again. But the correct answer is to do the same thing over and over without writing the same code. Goes back to our example, right? At the beginning, the course wrote console.log 0, console.log 1, console.log, and so on and so on. The loop lets us just console.log I, and the let I equal 0, I less than 10, I plus plus takes care of the running that code over and over again. Okay, on to exercise 5. Okay, looking at the code on the left, it says, why does the code on the left print 0 to 99 and not 0 to 1000? And let's, even though I've already answered this one apparently, with the answer, because console.log I only happens while I is less than, not equal to 1000. It says, the other options include, because console.log only happens while I is greater than or equal to 1000. Well, that's not the condition that's written here. Another option was because console.log only happens while I is greater than not equal to 1000. Again, that's not the condition shown here. And another possibility, because console.log only happens while I is less than or equal to 1000. Again, not the condition that we have here. Let's go on to loops continued. We can generalize the structure of a for loop as follows. For init, condition, post. Init runs at the beginning of a loop. Here we typically initialize a variable for use within the loop. Conventionally, this variable is simply called I for simplicity. simply called I for simplicity. I kind of like that. Condition is the run before each iteration of the loop. If the condition evaluates to true, then the loop body is executed. Otherwise, the loop is broken and ends. Post is evaluated at the end of each iteration. This is typically used to modify the value of a variable. Another example that prints 0 through 99 ascending. For, paren, let I equal 0, semicolon, I less than 100, semicolon, I plus plus, paren, brace, console.log, paren I, and the closers. Assignment. Use the decrement operator instead of the increment operator to write a for loop that prints all the numbers from 9 down to 0. Okay, so following the example here, we start with for. We have let I, we're going to start at 9. Let's say I greater than or equal to 0. Let's say I minus minus. And we need to print it. Console.log of I. Run that. Correct, great job. Loops practice. We can use if statements within a loop, and we can also name the iterator variable, normally I, to whatever we want. Assignment. I wrote a loop for you that increments the age variable from 0 to 74. So we start at 0, we go as long as it's less than 75, and we increment by 1. In the body of the for loop, if age is less than 8, your code should print, you qualify for free meals, you are blank years old. This is going to be console, console.log of that, and I don't think we've done string formatting yet, so I'm just going to do string concatenation. So what have I done here? I have console.log. Can I move this to the side? Yeah, let's do that. Console.log, you qualify for free meals. You are plus age plus years old. Except I need we need an if statement. So what's that going to look like? That's going to look like if condition, close paren, brace, and in here, do something. What's the something we're going to do? That's just this print statement that I've already written. So let's put that in place. And what's the condition? If age is less than 8. So age less than 8. And then we can say else if age greater than 65, have another console.log. You qualify for retirement. You are blank plus age plus quote years old. Underscore should be the current value of the age variable. Let's run that. Oh, interesting. It prints out all of these. Only 0 through 7 and 66 through 74. Yeah, because age is less than 75. Okay, continuing on. Exercise 8 of 9. Sum game. Similar to the increment plus plus and decrement minus minus operators, the plus equal and minus equal operators can be used to increment or decrement a variable by a number other than 1. So for an example here, we have let number of enemies equal 10, number of enemies plus equals 2, and number of enemies is then 12. That's just kind of the same as if we had done number of enemies equals number of enemies plus 2. It's not just kind of the same, it's the same outcome, exactly. Okay, let number of enemies equal 10, and number of enemies minus equal 2, then you have number of enemies is 8. The course goes on and says, let number of enemies equal number of enemies plus 2 is the same as number of enemies plus equals 2. Assignment, fix the bug in the program. Instead of adding 1 to sum at each iteration of the loop, it should add I. For example, instead of 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus... Okay, that's enough. We want 0 plus 1 plus 2 plus 3 plus 4 ... So instead of sum plus plus, let's say sum plus equals I. And again, that's the same as writing sum equals sum plus I. TV Josh says, hello. TV Josh asks, you're doing Boot.dev for $29 a month? Well, actually, I took part in a Boot.dev hackathon, and I am doing Boot.dev for free because I won the hackathon. TV Josh says, nice. Thank you, TV Josh. Yeah, I don't know if they're going to run another hackathon like that sometime soon. Yeah, I won a year of it, so I'm taking advantage of that while I can. Let's see, where were we? Did I finish this one? Yeah, correct. Great job. Okay, we can move forward. Sum game 2. Write a program that sums all the numbers from 0 to 99, but skips even numbers. Start your loop at a different number and increment your for loop by 2 instead of 1 at each iteration. I was all getting ready to write another if condition, you know, like if number is even, sum plus equals I, but there's a different way to do this. Oh, skips even numbers. So we want to check if it's odd. So if we start at 1 and say I plus equals 2, that should get the job done. Huh, interesting, the number is 2500. I feel like that's not a coincidence. Right? Because if we did the numbers 0 through 100, I've seen this proof elsewhere. You can like 0, 1, 2, 3, TV Josh asks, you know the closed form formula? No, I don't know that. But if we go 99, 98, etc. down to 0. TV Josh says n times n plus 1 over 2. If we add all these, okay, n times, here I'll write it out. Times n times paren n plus 1 divided by 2. Divided by 2. Let me think about this one. If we have the numbers 0 to 100, this whole thing equals 100 times 100, is that right? Except maybe we need the... Something tells me we have to do 101 here. And then it equals 10, 10, and you divide it by, and then you divide that by 2. 10, 10 divided by 2 is 50, 50. No, but that doesn't come out to 2500 either. Okay, I'm gonna stop pretending I know what I'm talking about here. TV Josh, tell me about this n times n plus 1 over 2. Is that saying that the sum from... Let's do this with... Do it for 1 to 10. I plus equals 1. Console.log sum, and that's also console.log 10 times 10 plus 1 divided by 2. And comment out this line. Yeah, 55. Let and we'll try it at 25. Yeah, it works for 25, works for 10. I'm sure it would work for any other number I tried. But let's go back to doing what this thing is supposed to be happening. One, 2, 99 with plus equals 2. Okay, that's that. And I think that does it for this course, which is why I'm pressing the forward button and I'm not getting anywhere further. Okay. This would be a good time to grab another break time. BRB screen. TV Josh, how are you doing today? TV Josh says, good, thanks. You? Yeah, I'm doing well. The sun is shining. You can see it in my background. And let's see, I want to change up how I'm doing the BRB timer. That's good enough for now. Yeah, I'm doing well. I'm starting my new job on Tuesday, which I'm kind of excited about. And let's put in a filter on this thing. Like 300 on the left. More than 300 on the left. Good enough. Yeah, I'm doing well. Just doing some Friday afternoon streaming. I think I'll keep going with this Boot.dev stuff for a while. I want to make it through pretty quick, pretty soon. I want to make it through their all of their JavaScript courses, so I have all those up on YouTube. And then we'll see what I get to next. Probably let's take this 500. That's better. Probably get up to some coding game later today, because that seems to be the most popular one with viewers. Oh, there's that. Go back to scene. Actually, let's hide this thing. Okay, so I jumped into learn to code in JavaScript 2. So this is course 2. TV Josh says coding game is nice. Yeah, I like coding game. I think that would be a good one to do a little bit later tonight. Okay. So, getting into arrays. From this course, a natural way to organize and store data is in the form of lists. In JavaScript, a list is called an array. Think of all the ways you can use and how many of the items in the app... Think of all the apps you use and how many of the items in the app are organized into lists. For example, a Twitter feed is a list of posts, an online store is a list of products, the state of a chess game is a list of moves. This list is a list of things that are lists. That's kind of cute. Arrays are declared using square brackets with commas separating each item. Let inventory equal, quote, iron breastplate, comma, quote, healing potion, comma, quote, leather scraps. Arrays can contain any data type. In our example above, we have an array of strings. Yes, but can they contain different data types within the array? That's something I don't remember about JavaScript. Assignment. Let's work on Fantasy Quest's inventory. We can store items the player is carrying in an array. Add a short sword to the end of the array. So we have let inventory equal square bracket, healing potion, leather scraps, iron helmet, bread, and let's continue with... before I do that, I want to see what happens if I try to add 55. Is that allowed? That is apparently allowed, but it's not what the question is looking for, so let's add in short sword. Oh, this thing isn't bouncing anymore. I kind of missed the bounce. Oh, I need to run. And then it bounces. Okay. Healing potion, leather scraps, iron helmet, bread, short sword. and it prints them without spaces on the printout, even though we gave it spaces here. So those spaces are not very meaningful to the computer. Exercise 2, arrays continued. Sometimes when we're manually creating arrays, it can be hard to read if all the items are on the same line of code. We can declare the array using multiple lines if we want to. Let flower types equal square bracket, daffodil, rose, chrysanthemum. Keep in mind that this is only a styling change. The code will run correctly either way. When would you declare an array on multiple lines? The answer that I've already given is when there are many items and it's hard to read them all on one line. And that's the correct answer, so let's move forward. This is review, so we'll move to the question. Which types can be stored in an array? Strings, numbers, all of them, or Booleans? The answer is all of them. Counting and programming. In the world of programming, even counting is strange. We don't start counting at 1, we start at 0 instead. Indexes. Each item in an array has an index that refers to its spot in the array. Take the following array as an example: Bob, Lane, Alice, Brianna. Index 0 is Bob, 1 is Lane, 2 is Alice, and 3 is Brianna. The question says which index refers to the second item in an array. Here we've got Bob and then Lane. Lane is the second item, and Lane goes at index 1. There was a way of speaking I kind of invented for myself, which is, you can say like the first and the second and the third. Well, you can say the 0th, and then you can say the 1th and the 2th, which sounds funny, but helps me in my mind to remember that I'm referring to indexes from a 0 index. Array access. Now that we know how to create new arrays, we need to know how to access specific items in the array. We access items in an array directly by using their index. The syntax is as followed. Let best languages equal JavaScript, Go, Rust, Python, C. Well, this is an opinionated course. Console.log best languages bracket 1. Prints Go because index 1 was provided. So if we count from 0 to 1, there we have Go. Assignment. We need to allow our players to access items within their inventory. Change the value of item index to the index in inventory that holds the value leather scraps. So we want to pull out leather scraps. We count 0, 1. Item index equal 1. Let item equal inventory at item index. Let's run. Correct. Great job. Very cool. Array length. Arrays have a property that allows us to easily get the current length of the array. The length of the array is equal to the number of items present. Don't be fooled by the fact that the length isn't equal to the index of the last element. In fact, it will always be 1 greater. Let's look at why it will always be 1 greater. If we have indexes if we have elements with indexes 0, 1, and 2, why did that? Oh, because I did tab. Okay. We have a length of 3. So that's why it's always going to be 1 greater. The length of the array is equal to the number of items present. Don't be fooled. Yeah, we said that. You can get the length of the array by adding .length to the end of the array variable. So let my array equal index 0, index 1, index 2, console.log myArray.length prints 3. Assignment. Some of our players' inventories are huge, so looking through the entire list is cumbersome. Let's make an easy way for them to see the last item in their inventory. Set the last index variable equal to the length of the inventory array -1, you will need to use the .length property. Let's just check how long this is. Oh wow, it goes on and on and on and on and on, ending with an iron bar. I bet someone had fun coming up with all the things to put in that phony list. Okay, let last index equal items .length -1. And then they'll say let last item equal items at last index. Again, the square bracket to access the item at the index. Correct, great job. I love the dancing arrow up here. Array updates. We can change the item that exists at a given index. For example, we can change leather to leather armor in the inventory array in the following way. Let inventory equal leather, healing potion, and so on. Inventory at 0 equals leather armor, and the inventory array now equals leather armor, healing potion, iron ore. Assignment. We need to update the items in our player's inventory when they smelt iron into an iron bar. Update the iron ore element in the array to be an iron bar. You know, I'm kind of tempted to just type iron bar right there, but that's not really the spirit of the exercise. So inventory at position, what is this? This is 2 equals iron bar. That should do it. Yep. Exercise 8, push values. It's common to create an empty array and then fill it with values using a loop. We can add values to the end of the array using the push method. Let cards equal empty list, cards.push NVIDIA, cards.push AMD. The cards array is now NVIDIA and AMD. Assignment. We need to generate a unique user ID for each player in the game. An ID is just a unique number. Use a loop to add unique IDs of 0 to 99 to the player IDs array. So it's just player IDs dot push, and we push I, and then we have it. Goes from 0 all the way up to 99 because it's less than 100. Remember how our loops go? We have I equals 0, that's the starting point. I less than 100, that's the condition to continue. And I++, that's the change that happens after each iteration of the loop. Pop values, exercise 9. Pop is the opposite of push. Pop removes the last element from the array and returns it for use. For example, let vegetables equal broccoli, cauliflower, cabbage, kale, tomato. Last vegetable equals vegetables.pop. Now last vegetable equals tomato, because that was the last one in the list. And the vegetables equals broccoli, cauliflower, cabbage, and kale. Assignment. Our player is selling the items in their inventory to the vendor. Pop and print all the elements from the existing array using a loop. So it's using I minus, which is why it starts at inventory.length -1. That's the last index, if you remember from before. We're using I greater than or equal to 0 as the continue condition, and I minus as the update. We're saying let item equal inventory.pop, and it's going to say console.log selling item. At the end, console.log inventory should show an empty list, or an empty array. There's that empty array down at the bottom. Down at the bottom. Oh, come on. There it is, highlighted down at the bottom, and it's selling each of the items. Okay, going on to the next one. Exercise 10 of 14. Counting. Remember from the first course that we can iterate count over all the items in an array using a loop. For example, the following code will print each item in the sports array. For let I equal 0, I less than sports.length, I++, curly brace, console.log sports I. Assignment. Our players need a way to see how many copies of a specific item they have within their inventory. Within the loop, count how many times potion, bread, and short sword appear using the potion count, bread count, and short sword count variables, respectively. So I see we've got some template code here already made up. We have I is 0, I less than items.length, so it's gonna catch index 0, index 1, index 2, all the way up to index length -1. And for each of those, I'm actually gonna say let item equal items at position I, and then if item triple equal potion, we can say potion count plus plus. An else condition, else if item triple equal bread, we can take bread count, do bread count plus plus. Finally, else if item triple equal short sword, that's one word apparently, take short sword count, give that a plus plus, and let's run that. You have 4 potions, you have 6 pieces of bread, you have 3 short swords. Okay, that's good. That sounds good. Exercise 11, 4 of syntax. With newer versions of JavaScript, we can now use a clean syntax to loop over an array without keeping track of the index manually. Instead of index-based iterations, so we have things like woods equal oak, pine, maple. For let I equal 0, I less than woods.length, I plus plus, braces is for, braces is in console.log woods I. Let woods equal oak, pine, maple, for let wood of woods, console.log wood. It's kind of like we came in here and added a line that says let wood equal woods I, and then console.log wood. And they're effectively doing the same thing. Wood, the variable declared using the of keyword, directly accesses the value in the array rather than the index of the value. If we don't need to update the item only need to access its value, then this is a more clean way to write the code. When should we use for of syntax? One option was when we want to write code that is harder to read. That's not a great reason. When we need our code to be faster, well, it doesn't, I think under the hood it does the same things, but the answer is when we don't need to know the index, just the value. That's the time when we use it. And this is more about for of syntax, which is considered more clean, assuming both options will work. For of is the considered more clean, and I would say that's because it's just easier to read. Look at all this mucking about with indices and I equals such and such and semicolons. Here it's just let wood of woods. So that's that. Find the difference. We need to keep track of each character's levels in an array. When someone's level changes, we want to know about it so we can congratulate them. Find any differences between old character levels and new character levels. When you find one, print the index where the levels are different. Loop over both arrays at the same time and print the indexes where the items in the arrays differ. For example, if the arrays were I may have missed when TV Josh said, "Hell yeah, Neo." What was that in reference to? Sorry, I missed that. Let array 1 equal 25375. Let array 2 equal 251978. Your code would print 2 and 4. TP Josh says you got the answer. Like on this thing? Huh. Okay. What we need here is the condition. And this code seems to be assuming that the lengths of the arrays are the same, and it looks like they are. If old character levels at position I triple equals new character levels at position I. Oh, except when you want them to be not equal. So do I want not double equal or not equal? I think it comes out to the same because the types are the same. So I think earlier it said programmers tend to use not double equal. All right, let's try that. Correct, great job. TV Josh says, yeah, okay, cool. Going on to 14. Well, let's review what happened here. We have an if statement, and the condition is old character level at I, so like here, and new character level at I, so there, and if they're not equal, console.log I. Okay, moving forward. Okay. Create an array of odd numbers. Assignment. Create an array of the odd numbers between 0 and 299 inclusive. Looks like it looks like it's setting us up to write an if condition, but I'm actually going to use the trick from before and say I plus equals 2 and say odd numbers dot push I. Remember, dot push will add I to the end of the array. Let's try that. Correct, great job. Okay, that does it for chapter 1. Let's see what's in the next chapter. Ooh, functions, nice. However, I'm going to drop onto a quick break. Gotta keep myself fresh here. Hit that BRB screen. Okay, we are coming back onto stream. Scene. All right. We have Chapter 2 is functions. Exercise 1 of 20. Important topic to have all that many exercises. Just out of curiosity, what are the other ones? Chapter 3 is objects and Chapter 4 is challenges. Functions allow us to reuse code that is helpful in multiple scenarios. For example, let's pretend we need to calculate the area of a circle. We can use the formula area equals pi times r squared, or in code, let r equal 5, let area equal 3.14 times r. This works great. The problem arises when there are multiple places in our code that need to get the area of a circle. Then we end up writing things like let r equal 5, let area 1 equal 3.14 times r, let r2 equal 7, let area 2 equal 3.14 times r2, let r3 equal 11, let area 3 equal 3.14 times r3. We want to use the same code, why repeat the work? Let's declare a new function called area of circle. Note that the function keyword is written before the function name and tells the computer that we're declaring a new function. Function area of circle r, braces, return 3.14 times r. The area of circle function takes one input, also called a parameter or argument, and returns a single output. We give our function the radius of a circle and we get back the area. To use the function, we can pass in any number as the input and capture the output into a new variable. Let radius equal 5, let area equal area of circle as a function of radius. The radius variable is passed into area of circle as r. That's r up here. After area of circle is done running, the result is returned using the return keyword. That's return here. The value returned is captured using the assignment operator equal into the area variable. That's over here. Now the assignment says on line 6, add a second function call to area of circle that passes 242 in as the radius. So that's area of circle as a function of 242. Capture the result in a new variable called big area. So for that we need to let big area equal area of circle 242. Let's try that. Correct. Okay, good. Multiple parameters. Functions can have multiple parameters, also known as inputs. Function add numbers of a and b, return a plus b. So again, a and b is what goes into the function, and the return keyword tells us what comes out of the function. Assignment. Until now, we have been adding up the damage a player deals every time they attack. Let's write a function called calculate damage that takes 3 numbers as its parameters and returns the result of adding them all together. Looks like it's already been done for me. Let's just run this. That's confusing. Well, let's read the function. It says function calculate damage as a function of x, y, and z, braces, return x plus y plus z. Might need to mention this to someone, that this one is a little confusing. Where to declare functions. You've probably noticed that a variable needs to be declared before it's used. For example, the following doesn't work. Console.log my name, let my name equal Lane Wagner. That doesn't work. We can convince ourselves of that here. If we run this, Reference error, cannot access my name before initialization. Yes, reset the code. It needs to be let my name equal Lane Wagner, console.log my name. Code executes in order, so a variable needs to be created before it can be used. Functions break this rule. Because functions don't execute until they are called, they can be defined before or after the function call. Let sum equal add34 console.log sum. Then the function is defined. Function add a comma b, return a plus b. That's a little mind-bending for me. But I guess all of this code must get read into the computer and or read into, is it a interpreter for JavaScript? I think it's an interpreter. Gets read into the interpreter. So by the time this actually runs, add has already been defined. Assignment. Let's create a function that allows players to print their character's full name in case they forget it. Define a new function at the end of the code called print name first and last. It should concatenate its two inputs and use console.log to print the result. So we can see that the provided code is already saying console.log print name of Frodo and Baggins. So the syntax again is first we write function, then we write the name of the function, that's print name. We define the inputs, first name and last name, let's call them that. We add our braces. This actually says define a new code at the end called print name of first and last. So we'll actually call this first and last in the way that it says. And then it's going to return first, last, and I'm going to put a space in the middle, even though I'm not sure if that's what it wants. It is what I want. Let's run. What if I took out the space? It's also correct. What if I put in too many spaces? Huh. That's a little surprising. Okay. Scope. Scope refers to where a variable or function is available to be updated or read from. For example, when we create variables in a function by giving names to our parameters, for example, that data isn't available outside the function. For example, function subtract x, y, return x minus y, let result equals subtract 5, 3, console.log x is undefined, print nothing. Let's convince ourselves of that. Reference error, subtract, subtract. Well, that's interesting. That's better. Reference error, x is not defined. When the subtract function is called, we assign the variable x to 5, but x only exists within the subtract function. If we try to print x outside of that function, then we won't get a result. Assignment. Find the bug in the code and fix it. Obviously the bug is that we're trying to print x out here when we don't have access to it. The question is, what is the code supposed to do? I'm going to make an assumption that it's supposed to print the result. Reset code. Wait, did I reset it? Oh, okay, never mind. Huh. That's better. Oh, okay, so let's look at this. Function get area of square as a function of height and width. Return height times width. Then we define let my height equal 4324. Let my width equal 5432. Console.log get area of square, height, width. Oops. This height and width is the same as inside of the function, get area of square, but we need it to be my height and my width, which are the variables available in the global scope. And when we run that, that's going to work out all right. Just for interest though, what if we go back to the way it was, try to run, reference error, height is not defined. That's because height only exists inside of the function. It doesn't exist out here where the function is being called. That's an interesting example. Okay, on to the next. Global scope. So far we've been working in the global scope. That means that when we define a variable or a function, that name is accessible in every other place in our program, even within other functions. For example, let pi equal 3.14, function get area of circle as a function of radius, braces, return pi times radius times radius. Because pi was declared in the parent global scope, it is usable within the get area of circle function. Assignment. Let's change how we are calculating our player's stats. The only thing we should need to define globally is the character level, and then let our functions do the rest. Declare the variable player level in the global scope and set it to 4. Okay, just that simple, huh? And we need to let player level equal 4. Run the code, and let's see what's happening in this example code. Let player health equal 4, function calculate health of modifier, return player level times modifier, function calculate primary stats of armor bonus comma modifier, return armor bonus plus modifier plus player level. Okay, that makes sense. And this is just printing the stuff. So the thing to notice is that player level was defined out here in the global scope, and it's available to this function and to this function. Scope quiz. Can functions access variables declared outside in the global scope? Yes, they can. Scope quiz. Can code access the scope of a function, Can code outside the scope of a function access variables that are inside that function? No, it cannot. That's like, an example of that is function, I don't want to write it here. I'm going to back up a few. That would be like function add x comma y, return x plus y, and then we go along and try to say console.log x. That doesn't make any sense because x is not defined outside of the function. Answer is no. Okay, we can go forward. Functions practice degrees. Let's take a break from working on Fantasy Quest for a moment. Instead, we will use what we've learned to build a function we could use in the real world. Write a function called toCelsius that converts the temperature in Fahrenheit to Celsius. So, function toCelsius. Oops. We'll say f be the I'll type it up, Fahrenheit. And let's see, I know there's a 9/5 and there's a 32 in there somewhere. How does it work? I think it's return you take the Fahrenheit value, you subtract 32 from it, and then you multiply by 5 and divide by 9. Okay, that's good. I'm glad I remembered how to put that formula together. So to review, we have a function, the name of the function is toCelsius. The parameter is Fahrenheit, and when we execute the function, we return that number for Fahrenheit, like it was 100 here, minus 32 times 5 divided by 9. Oops, don't want to move those around. Okay, moving forward. Functions practice exists. Let's get back to working on Fantasy Quest. We need to make a way to easily check if an item exists within our inventory. Complete the string exists function that checks if a given string can be found within an array. For example, string exists Sally in Bob, Joe, Bill returns false. String exists Sally in Bob, Sally, Bill returns true. And I can see that we've got some template code prepared for us. So we're defining the function string exists. We have string to check. We have string array. Let's look at an example of the data. String array could be iron bar, leather scraps, short sword. And the string to check could be healing potion. In that case, it's going to be false. Let's say that for I equals 0, this is the pattern we've seen from before, I less than string array dot length I plus plus. So what's that going to do? It's going to start at 0. It's going to iterate until I is not less than string array dot length, and it's going to go I is greater by 1 every time. Next, the condition, we can compare if, oh, we already have if, if string to check triple equals string array at position I. Return true, else we return false. Let's run that code. Correct. Okay, so again, this was an if block. The condition lives inside of the parentheses, and the condition I wanted to check was whether string to check is equal to the current element from the string array. And how do I get that? I take the string away and I address at the I index. Boolean logic. Boolean logic refers to dealing with Boolean, true or false values. For example, dogs must have 4 legs and weigh less than 100 kilograms. Both conditions must be true. Cars are cool if they go faster than 200 miles per hour or if they are electric. One condition must be true. Syntax. The and operator takes a Boolean value on each side and returns true if both values are true. So function is dog with number of legs and weight, return paren number of legs equal 4 and weight less than 100. Let's go over how this function evaluates given the parameters 4 and 99. Return 4 equal 4, that's true. 99 less than 100, that's true. So it's like it does return true and true. Now this AND operator takes the true and gives us true. Let's see what would happen with 3 and 98 instead. The function will return 3 triple equal 4, AND operator, logical AND operator, 98 less than 100. So that comes to false, logical AND operator, true. And since it's not both conditions, it is returned false. It says the logical AND operator will only return true if both conditions are true. The bar operator, which is the logical OR, returns true if either of the conditions are true. Functions is car cool, speed is electric, returns speed greater than 200, or is electric. Let's use a non-electric car that can do 250. Return 250 greater than 200, logical or false. So we're returning true or false, and that evaluates to true. So the function gives true. Assignment. We need a way for our game to track if a character's attack hits or misses. Complete the doesAttackHit function. The function should return true if either of the following conditions are met, so I can already put in an OR operator for the middle. If either of the following conditions are met, that's a typo there. The attack roll is not a 1, and the attack roll is greater than or equal to the armor class. So we actually need a paren and an AND operator in here. So attack roll not equal 1. And attack roll greater than armor class. And I'm going to put an extra paren in here, even though I think it's not necessary. I think that the greater than operator takes higher precedence than the logical AND operator, and I think the same thing of the not equal operator, but I'm going to put in parentheses there to make that explicit as well. The other OR is attack roll equal 20. Let's review this. This is a typo there. Return, we have condition of attack roll not equals 1. That's attack roll is not a 1. And attack roll is greater than armor class. And attack roll equals 20. Now let's see about what these are going to come out to. The attack roll is 17 and the armor is 18. So that's going to come out to, I think, false. Because the attack, we don't have that attack roll is greater to armor class. And we also don't have attack roll is 20, so this will be false. For the next one, does attack hit with 20 and 25? Well, we have attack roll equals 20, so that's true. This one's interesting. Attack roll is greater than armor class, so we get true here. But attack roll is equal to 1, so this not equal to 1 condition is false. So this whole AND thing is false, and this is gonna come out as false. What about 16 and 13? 16 is greater than 1, and our attack roll is greater than armor class, so we have this side satisfied, so that should be true. Next we have 25 and 21. We're okay on the left, on the overall left side, because attack roll is greater than armor class and attack roll does not equal 1. So that should be true. So if I did this right, we'll have false, true, false, true, true. False, true, false, true, true. Right on. A little bit longer to go before a break. Boolean quiz. Refer to the following Boolean statement. Let is tall equal true. Let is fat equal true. Let is skinny equal false. Let is short equal false. Let result equal is tall and is fat, or is skinny and is short. And we have true and true here. Those together with the AND operator will come out to true. And the OR operator with the false over here, we'll end up with true for this, or false for this, so it's going to come out to true. Hours to seconds. Let's take a break from fantasy quiz again to write another real world function. Write a function that converts hours to seconds. So we now have hours. We have our function. Remember, we write function for to define a function name, the function parameters. In this case, there's just 1 hours. And we can multiply times 60 times 60. That should give us the right return value. First element from array. Exercise 13. Let's do some more work on Fantasy Quest. Let's add another function to our inventory system. Write a function that returns the first value from an array. If the array is empty, then return the string error instead. So here's the error string. And if items.length greater than 0, that's our check, which will allow us to return items 0, index 0 for the item at the first position. Function get first item of items. Okay, that's correct. Time for 1 or 2 more exercises. Should serve drinks. Assignment. In Fantasy Quest, players can go to a town's local pub. Drinking virtual beers refills their stamina. Complete the function that determines if a bartender should serve drinks to a customer. The function should return true only if all of the following conditions are met. The time is between 5 and 12 inclusive. The bartender is not on break. The customer's age is 21 or older. Tip: if statements don't need a comparison. What do they mean by that? Where is big is a Boolean value, the following statements are identical. If is big or if is big equal to true. Oh, I see the difference. You should actually prefer the first option, however, because it tends to be more readable. The equal true is strictly redundant. Makes sense. Function should serve customer with customer age, on break, and time. So we're checking customer age first. If customer age less than 21, return false. That takes care of the customer age. If on break, return false. And if time less than 5, or the other one is time greater than 21, return false. And if all those get through, return true. Notice how we don't have to write else return true, because the function is, once a return keyword gets hit, that's the end of the function execution. Correct, okay. And there it is, time for a stream break. So let's get our short timer. Go onto our BRB screen. Okay, how we doing? I think I'm going to finish out this section on functions in this Boot.dev course, and then I'm going to either call the stream for now or move on to coding game. We'll see which one comes through. Let's see, scene. Okay. Right. Return true. We got through this one, so let's go on to the next. Find max. Our players want to see their strongest attack from their last combat. Let's add another function to analyze data from our combat log. Complete the function that looks at each number in an array and returns the maximum value. So we have our function find max of nums, let max so far equals 0. I guess we're assuming that nums must be greater than 0. We have a -1 here, but that doesn't end up hurting the overall answer. For let I equals 0, I less than nums.length, I plus plus, let num equal nums I. If, so we need to fill in an if condition, and if that comes out to be true, then max so far equals num. I'm going to say that that condition is if num greater than max so far. And then after all of that, after the if for loop with the if condition, return max so far. That should do it. Okay. Reverse array. Some of our players would like to view their inventories in reverse order. Let's write a function that takes an array as input and returns a new array except that all its items are in reverse order. For example, 1, 2, 3 goes to 3, 2, 1, and A, B, C, D goes to D, C, B, A. I think the simplest way to do this would be, well, we already have function reverse array of items. We have new array is an empty array. And we have for let I equals item.length -1. So we have the last index. I greater than or equal to 0, I minus minus. So I is going to be, length and length -1, or excuse me, length -1, which is last index. So I is going to be last index, and then second to last index, and then all the way down to 0. So we can just say new array. We can use a function we learned a while earlier today, which is push. And we can push items at I. Because items at I, that'll be the element in the I position of items. Okay. So from short sword to healing potion and so on, it prints kite, shield, iron breastplate, healing potions, short sword. Yep, that looks right. Read the first several paragraphs of this article on pure functions. Okay. How to make pure functions in Go. Pure functions are often hyped up in JavaScript world, particularly because of the abundance of stateful front-end applications. While pure functions have their downsides, i.e. inconvenience, potentially large argument lists, they should be used as much as reasonably possible. What's a pure function? According to Wikipedia, a pure function has the following properties. Its return value is always the same for the same arguments. Its evaluation has no side effects, no mutation of data outside of the function. Which means that as a developer, I know two important things. When I call a pure function, I will get the same result every time. After calling a pure function, the rest of my program will be in the same state it was before calling it. So that brings us to this question: what is a pure function? A function with no side effects. It returns the same values when given the same inputs. Are pure functions generally harder to test? I would say pure functions would generally be easier to test because their results can be more predictable and isolated. And that's what the correct answer is according to this course. Okay, 19. exists a pure function. Pure function considered. Refer to the following code. Let threshold equal 10. Function get area of circle. Get function convert hours to seconds. Function exists. Items or exists item and items for let item in array of items if item equals item in array return true. So let's analyze this. Is there anything in here that depends on something other than the inputs? Well, no. It's we have a new variable, let item in array, but that only comes from the values in items. And we're checking if item equals item in array, return true. So it's going to give the same answer every time we call it, and it's not going to change any other existing data. Now let's say, is tall a pure function? Well, actually it's not, because it depends on the value of threshold. And is tall of height could give different results depending on whether threshold, was 7 or 38. And this function is perfectly capable of running when there are different values of threshold in place. So is tall a pure function? The answer is no. Okay, we got through that pretty quick. I hesitate to take another break already, but I don't think I want to jump into objects just like that. So let me, it's a little silly to take a break again already, but let me take a stream break, and we'll decide then what to do next. Hey chat, hello. What do we want to see next? I think I've done enough of Boot.dev for now. And it might be time to call it on the stream. Or it might be time to take like an extended break and then get into coding game. Although if I'm going to do that, maybe it makes more sense to take a pause on the stream anyway. I don't know. This music almost lets me go to sleep, even though I'm on stream. I'm feeling like I'm going to call the stream for now, but I bet I'll be on later tonight. I'll get myself ready to go and do a good long coding game stream a bit later. So for now, thanks all for watching, and